Hi guys, and welcome to this session on MeanStack by Intellipaat. MeanStack is a collection of JavaScript technologies which are used to create web applications. So in today's session, we'll discuss about MeanStack in detail. But before we get into all of that, please subscribe to our channel to never miss an update from Intellipaat. Now let's talk about today's agenda. So we'll start this session today by talking about what is MeanStack along with its advantages and disadvantages. Then we move on to Node.js, where we discuss about Node.js, NPM, as well as ExpressJS, which is a framework on which Node.js works on. Then we move on to MongoDB, where we see about MongoDB and understand it through a simple hands-on. And finally, we'll wrap today's session up by talking about Angular and its various components. Guys, this session has a lot of hands-on, so I recommend you to try all of them. Also guys, we do provide end-to-end training on MeanStack. So if you're interested, you can check out the course details given in the description below. Now, let's get into the session.
MeanStack is a software stack that completely uses JavaScript to build dynamic web applications. Mean is an acronym in which each letter stands for the name of a technology in the stack. So in the MeanStack, M stands for MongoDB, E stands for ExpressJS, A stands for Angular, and N stands for Node.js. In this session, we'll be looking at what each of these technologies is and why would you use it. So let's look at some of the advantages of MeanStack. Now, MeanStack offers several advantages. One of the major advantages of MeanStack is that it only uses one language, that is JavaScript. So it used to be that you used to create your front end in HTML, CSS and using some JavaScript, and then back end was created in some other language like Python, PHP, Ruby, or any other language. In MeanStack, we can use JavaScript to create both front end and the back end. So developers can use just one language, that is JavaScript, to build both the front end and the back end of the application. The second advantage is that it decouples the front end and the back end. So what it means is that earlier what used to happen is the front end and the back end were tightly coupled. That is, changing something inside in the front end, that is the design of the web page or any other component of the front end, would lead to some changes in the back end. Now when we're using MeanStack, we can develop both the front end and the back end separately. That way, changes in either of those components of a web application will not lead to changes in the other component. It uses JSON. JSON stands for JavaScript Object Notation. So the data is exchanged between the front end and the back end using a format called JSON, which is lightweight, easy to use, and is mostly used by most of the web applications online. And finally, it has a very strong community. So there are a lot of developers who use MeanStack, and having a large community associated to the software stack that you use provides you with the advantage of having, if you ever run into a problem, then there's a good chance that a developer has already run into the problem and has found the solution and has posted about it online. Also, if you run into a problem that you haven't seen before, or maybe someone hasn't, so what you can do is you can post about it online and the developers in the community can help you out. So let's look at some of the disadvantages of MeanStack. Now MeanStack, since it's built in JavaScript, has some of the disadvantages that JavaScript has. So one of these are dynamically typed. So JavaScript is a dynamically typed language, which is to say that it does not have a built-in implicit type system. So if you create a variable that is storing a string right now, it could later store a number as well. Now this might be considered an advantage for smaller applications, but for larger applications this could lead to some problems. So this is why JavaScript was usually frowned upon. Now there are technologies like TypeScript which try to solve these problems. However, JavaScript itself is a dynamically typed language, so this could lead to some problems. It's not suitable for small applications. So creating an application in MeanStack requires a lot of setup. You'll have to create the back end, then you'll have to create the front end, then you'll have to create an API in back end, then the front end would have to authorize that API and then get the data and then show it in the front end. Now these are a lot of steps, and for creating a really small application, these steps are a bit of an overkill. So if you're creating a small application, using MeanStack is not really a good choice. Requires a good understanding of JavaScript. Since JavaScript is the language that the MeanStack uses, you need to have a very firm understanding of what JavaScript is, how to do certain things in JavaScript. If you have a good understanding of the basics of the JavaScript and are somewhere in the intermediate level, then using MeanStack could be good for you. However, if you are not well versed with JavaScript, using MeanStack is going to be extremely difficult. And then finally, there are some problems in JavaScript. One of them, as we mentioned before, is dynamically typed, but there are some other oddities and quirks in the language. So there are certain problems with inheritance. The inheritance in JavaScript is quite different from the way you inherit things in Java or any other language that supports object-oriented programming. So you need to be very well aware of these changes in order to be able to work with MeanStack.
Just a quick info guys, Intellipaat does provide end-to-end training on MeanStack. So if you're interested, you can check out the course details given in the description below. Now let's get back to the session.
Now let's look at what Node.js is. So Node.js is a JavaScript runtime environment. It allows developers to write and run code in JavaScript on the server. So you can write your backend in JavaScript and Node.js will run it for you. Node.js is used by developers to write server-side backend of the web application. It allows them to create the backend using JavaScript, which is the same language that is used on the front end. So if you are a front end developer who is looking to get started with backend development, then Node.js could be a good option for you since you already know JavaScript and Node.js uses JavaScript. Now, what are the advantages of Node.js? Well, first of the advantages of Node.js is its ease of use. So Node.js is very easy to learn. Given that you already know JavaScript is a pretty easy language to understand, so picking up Node.js is not going to be very difficult. It's asynchronous, which means that it's non-blocking. If there is a task that needs to be performed on the server that is going to take a lot of time, like processing images, sending emails, and crunching data from the database and then creating some sort of an equation, things like that, time-consuming tasks can be pushed off from the main thread to keep the application or the server responsive to serve future requests. And finally, it has a built-in package manager. This is one of the major advantages of using Node.js. It has a built-in package manager that is known as NPM, or the Node Package Manager. It allows us to include code written by other developers into our own project so that we don't have to recreate the same functionality that has already been created. So let's move on to the next slide. Now let us look at NPM. So what is NPM? NPM stands for Node Package Manager. It is the built-in package manager for Node.js. It allows developers to include packages, that is code that other developers wrote in their project, and then use that code. NPM manages packages by installing the user-specified version of the package. So if the user specifies a specific version of a specific package, only that version of that package will be installed. So why would you use NPM? NPM allows code reuse by allowing developers to share packages that they have written for common tasks. These common tasks may include data validation, data access, etc. NPM also makes the projects portable on other machines. So the developers can use your project by installing the packages that the developer has specified. So for instance, let's say that you have created a project which uses a specific version of a specific package. Now when you move that project to another developer's machine for them to test or for them to use, they only need to type in the command npm install and all the packages that you specified will be installed for that project, and then they can begin using that project without any problems or worrying about version mismatch. So let's look at ExpressJS. So what is ExpressJS? ExpressJS is a server-side web application framework for Node.js. It is a minimalist and unopinionated framework that reduces boilerplate code and allows developers to easily build common web application features such as request routing, templating, etc. So why would you use ExpressJS? ExpressJS offers several benefits. So some of them are that it provides built-in support for routing. Now, routing is the process of taking an HTTP URL request and then performing certain action on it. So routing allows us to describe what are the URL endpoints that our application will respond to and how will it respond to those URL methods. Next, we have templating. Templating is the process of combining static views and dynamic data to generate dynamic content for the user. So for instance, let's say that you have a user who just logged into your website, and after logging in you want to display their username and the last time that they logged in. Now this is the kind of content that we call dynamic content, since it changes on every user. Another user might have a different name and the different time that they logged in on. So for generating content like this, we use templating. Templating simply uses templates which contains static placeholders. So what you can do is you can just specify, okay, in this place, this is the content that I want to display, and I'll pass it after fetching it from the database. And the templating system will then that can generate the dynamic content based on the templates. Now Express does not have a built-in templating engine, but it supports several other templating engines such as handlebars, embedded JavaScript or EJS, bug, etc.
Just a quick info guys, Intellipaat does provide end-to-end training on MeanStack. So if you're interested, you can check out the course details given in the description below. Now let's get back to the session.
And then we have support for middlewares. So ExpressJS allows us to write middlewares. A middleware is basically a function that has access to request and response variables, and then it gets executed during the request response cycle. So it allows us to check if the user is authenticated, if the user has sent specific headers along with the request that it sent, so on and so forth, and allows us to manipulate and change the behavior of our application based on the request that came into our application. Now let's look at MongoDB. So what is MongoDB? MongoDB is a document-based NoSQL database system. MongoDB stores data in a JSON-like format. Now this is a JSON-like format, it's not exactly JSON, and this format is a slight variation of JSON and is called BSON, which is binary JSON or binary JavaScript object notation, and it stores data in documents. So why would you want to use MongoDB? So MongoDB has several advantages. One of them is high speed. MongoDB allows documents to be indexed and provides fast query responses. MongoDB is written in C++, so the queries that you run will be extremely fast. MongoDB is schema-less, allows us to create our data models with great flexibility. Now it is schema-less, which means that if you do not wish to add any database level schema for data validation, you can do so. However, if you choose to add some validation, you can do that as well. It's easy to scale. MongoDB can be scaled very easily to handle large amounts of data by just spinning up new clusters. And finally, because it's NoSQL database, it allows us to perform data queries that do not require complicated joins. If you worked with an SQL database like MySQL, SQLite, PostgreSQL, and so on and so forth, in which data is stored in tables in forms of rows and columns, this allows us to then, when you need to get data from multiple tables, you need to perform some very complicated join queries. Now in MongoDB, since it's a NoSQL database, we can embed documents inside other documents and get great flexibility to get data without performing complicated join queries, and it speeds up our queries quite fast. Now let's look at MongoDB terminologies. MongoDB has several terminologies associated with it. So firstly, it's NoSQL. So a NoSQL database is a database that is not modeled in the form of tables with rows and columns, but in other formats such as documents, which MongoDB uses. There are other NoSQL databases that model the data in the form of columns, graphs, XML, so on and so forth. There are documents, so MongoDB stores the data that we wish for it to store in documents. A document is a single record in a collection, so it is similar to a row in a database. Now collections are the same as tables in a relational database. They store documents. As we discussed earlier, documents are rows and collections are group of documents. So in SQL terminology, MongoDB collections are same as SQL tables, and MongoDB documents are the same as rows, or you can say records inside an SQL table. And finally, BSON types. As discussed earlier, MongoDB stores the data that it stores in a special format called BSON, which stands for binary JavaScript object notation. It is a binary encoding of JSON-like documents and is used by MongoDB to store the documents. Now let's have some demos of how to use MongoDB and add and remove collections and data from it. So I'm inside my command prompt inside the folder where I've installed MongoDB. So now let's jump into the Mongo shell and perform some queries. So we have logged into the shell. Now let's look at the databases that we have so far. So we have admin, config, local, and my app. The admin, config, and local databases are pre-configured, and the my app database is the one that I created. So let's create another database to show you how to create one. All we have to do is use the word use and the name of the database that we want to create. So let's say we call it sample. You can name it anything you wish to. Now it says switched to DB sample. Now inside the database we need to create a collection to hold our documents. That is similar to creating a database. Inside the database we create a table, which is the collection, and then inside the table we create rows, which is similar to documents. So Let's create a collection on the database that we use. Right now there are no collections inside the database. It is empty. As you can see, show collections returns no response. So if you wish to create a collection on the database that we are using right now, we use db dot create collection, and you can pass in the name of the collection. Now you can name it anything you want. I'll be naming it users. Now it returns the response of OK, which means the collection was created. So as you can see, show collections now shows one collection that was created on the example or the sample database that we just created.
Just a quick info guys, Intellipaat does provide end-to-end training on MeanStack. So if you're interested, you can check out the course details given in the description below. Now let's get back to the session.
Now let's create a document inside the users collection, which is similar to adding some data inside the users table. So we go db dot insert one. Now MongoDB also has an insert many, which is good if you wish to insert multiple rows in a single query, but we only wish to insert one right now. So here, as you can see, we have not defined any schema. We can just type in the structure of the data that we wish to insert into the database, and MongoDB will insert it for us. So let's say the name of the user is John Doe and email is, so you can, let's say the name of the user is db dot users dot insert one, and the name of the user is John Doe, and the email of the user is john@example.com. Now when I press enter, it gives a response with acknowledged as true and insert ID with some object ID. So this means that the data was inserted into our collection. We can insert more data by running the same query with different parameters. So let's say now we create another record with Jane Doe. So it's inserted, and now let's insert another row with Sam Joe. Now let's look at all the data that we have inserted inside our users collection. So to fetch all the data, which is similar to select star queries from SQL tables, so we use db.users.find and we pass in an empty object, and we get all the data inside the users collection. Now if you wish to filter the data, that is to get specific rows, specific columns, we can do it like this. So let's say that we want the row of the data where name is equals to John Doe. So we can do it this way. Inside the find method, where we passed in an empty object earlier, we pass an object with the key as name and the value as John Doe. And as you can see, it returns us the data. Now let us look at how to update the data. So for instance, let's say that the name we inserted is John Doe, however it's incorrect. We want to insert the name of Johnny Doe. So what we can do is, first we use db.users.update1. Then we need to tell our database system, that is MongoDB, that we wish to update the document that has name as John Doe. And now what we want to do is we want to tell it to set, which is an operator in MongoDB, the name to be equal to Johnny Doe, and it gives acknowledged as true and matched count as 1 and modified count as 1, which means that the query we passed matched one row and it was able to modify that one row. Now if we look at the data, you can see that we have Johnny Doe here. And now finally we'll look at the delete operation or the remove operation. So we can do remove one, pass in the filter, which is name Jane Doe. Sorry, it's not remove one, it's delete one, and it gives us acknowledged of true and delete count as 1. Now if we look at all the data that we have, you can see that the row corresponding to Jane Doe has been deleted. So these are the basic CRUD operations, or create, read, update and delete operations inside MongoDB. As you can see, we didn't have to create any schemas. You can create a schema if you wish to validate some of the data and maintain the data consistency. However, we will be creating our application using JavaScript, and in that we'll be using a package called Mongoose that will handle data validation for us. So this is how you use the CRUD queries inside a MongoDB shell. But since we'll be using a Mongoose library, which is an object data mapping library, we won't have to issue any of these queries ourselves. That will be managed by the Mongoose package itself. So I think this is it. Okay, now that we have looked at some of the basic create, read and update and delete queries in MongoDB, let's move on to the next topic, which is Angular. So what is Angular? Angular is a front-end framework created by Google to build JavaScript-based single-page applications. So why would you want to use Angular? So Angular has several distinct advantages, one of them being that it's declarative, which basically means that it allows us to use HTML and define UI elements, that is the user interface elements, that is the lists, forms and any other thing that the user can see and interact with. We can just use HTML and create the structure of that UI element. Let's move on to the next advantage, which is component based. So Angular is component based. Angular uses components to architect its applications. This way all the apps are composed of small individual components that are easy to build and maintain, and then those components are arranged in a way that they form a tree structure. It supports MVC. So Angular supports the MVC, which is the model view controller architecture, and allows the developers to write code into three distinct layers, which is the model, the view and the controller. So the model is a layer that deals with the business logic, that is data validation and any other problem that you're trying to solve in the business perspective, that the code related to that is stored in models. Views are used for user interface, so anything the user sees and interacts with, like a button or a table, that is created in views, and a controller is the glue between model and a view. So the view is used by the user to interact with the application. When a user clicks on a button to perform certain queries or certain actions, the controller gets that request, then passes the request to the model, gets the data from the model, and then passes it again to the view. So controller is the middleman between the view and the model. And finally, Angular has the advantage of built-in support for testing. So Angular has built-in support for unit testing as well as integration testing. Angular uses Jasmine, which is a testing framework for its testing needs, and Karma as its test runner, which is also a package to run the tests that we've written in Jasmine. So let's break down some of the terminologies associated with Angular. So what is a single page application, or SPAs? A single page application is a web application that is written in JavaScript. In a single page application, when the user visits the website, an HTML page is firstly displayed to the user with all the required CSS and JavaScript, and then every subsequent interaction, instead of redirecting the user to a new HTML page, all the information that is needed for the user to see is fetched from within the same page by the JavaScript from the backend, and then is displayed to the user. So the JavaScript will take care of the navigation, adding and removing elements on the page, so on and so forth. Since there's only one HTML page involved, that is why it's called a single page application. Now let's move on to Angular CLI, or the Angular command line interface. An Angular CLI, or the command line tool, is basically just a command line utility created by Google for creating new Angular projects and components. It also helps generate new files like Angular components, services, modules, so on and so forth, as we'll see in our project, and allows us to just skip the boilerplate code that we'll have to write in order to get started with Angular. So when we generate a new component with this tool, it will register all the files correctly, and all we'll need to do is just fill in the information into that file. Now Angular supports modules. Now in Angular, a module is basically a group of code that is related to each other, such as components, services, so on and so forth. A module can import functionality from other modules and can export functionality that other modules can import. Modules are used to define business logic and are used to encapsulate certain functionalities. So if you wish to add routing to your front-end application, you can create a module for that as well. Components. As discussed earlier, Angular uses components to lay out views and the UI. Now, a component is used to build and manage the visible part of the application, which is the view. And in Angular, apps are composed of several components that interact with each other. And a component contains its markup, also called the templates, its style in CSS, and its logic written in JavaScript.
Just a quick info guys, Intellipaat does provide end-to-end training on MeanStack. So if you're interested, you can check out the course details given in the description below. Now let's get back to the session.
Angular also has a concept of services. So a service is really a broad category that contains code that performs a specific task, such as logging the data into a file, or maybe getting the data from an API, compressing an image, so on and so forth. Services are used by components and other services. So any task that is not related to UI or user interface is encapsulated in a service, and then that service is used by the components or any other service. And dependency injection. Dependency injection is the mechanism in Angular through which Angular provides new components with the services or other things that they need. Instead of you having to instantiate the dependency in Angular, Angular will pass the dependency into the constructor itself and will allow you to create applications much more quickly. Now, this is especially useful because when we are testing an application, dependency injection comes in handy. When we're creating applications that we need to test, we need to pass in the dependencies ourselves. And instantiating each new object for creating a component or a service can be a little messy and difficult at times. Angular takes care of that using its dependency injection framework. And now let's look at HTTP client module. Now, any web application or any front end of a web application needs to make requests to the backend to get the data and then perform certain tasks on it, or to post the data or to send the data as part of the request for the API to consume. So for that we use in Angular the HTTP client module. It allows Angular to interact with our backend using methods such as get, post, put, patch, delete, which are valid HTTP methods. Angular apps can use this package to make HTTP request to the backend server. When we create a REST API in ExpressJS, AngularJS will use the HTTP client module to make the request to the server to fetch the data or to store the data, to update the data, to delete the data using these methods, using get, post, put, patch and delete methods. So now let's build our application. So let's begin building our project in MeanStack. We'll be building a task manager application which will have lists, and each list will contain a task. You can toggle the tasks as completed or not completed, and you can delete the tasks and delete the lists as well. So the first thing we'll do is we'll create the project structure. So we'll have a separate folder for backend and we'll have one for frontend. The frontend will contain all of our AngularJS code, and the backend will contain all of our Node.js and ExpressJS code. And the backend will interact with the database and return the data as JSON to the frontend. Let's first begin by building the backend. Inside the backend, first thing we'll need to do is we'll need to create our ExpressJS project. For that, we'll need to install some dependencies. So we'll be going to the backend folder. Inside the folder, we'll be initializing an npm project. So for that, we type the command npm init-y. This will initialize an empty project. This file indicates that this is an empty project. And now what we need to do is we need to install the dependencies or the packages that we'll need. For that, for the project to work, we need ExpressJS and Mongoose. Mongoose is an object document mapper, which allows us to write code in JavaScript and interact with our Mongoose database. So we'll install npm install express and Mongoose. Press enter and it will install the dependencies that we have asked for. It will install the latest dependencies or the latest versions of the dependencies, since we have not specified a version. So it's installed Express 4.17.1 and Mongoose 5.7.7. Now after doing that, what we need to do is we need to create all the required files. So first thing we'll do, we'll create an app.js file. to test out if ExpressJS was installed correctly and if it's working properly. So what we can do is we'll first import ExpressJS. First express is equals to require express, and then we can create an express app. Now this application will use to listen to certain web requests. First we'll create a server using the app variable. In the listen function we'll pass in the port number, which is 3000, and then we'll pass in a callback. In the callback is basically a function which will be executed after the server is created on port 3000. Inside it will write server connected on port 3000. Now we can run our application using node app.js, and as we can see it says server connected on port 3000. Now if we want to use our server or see if it's working properly, we can go to the web address. However, it's not going to return any content yet because we have not programmed the server to do so. So as you can see it says cannot get / which is the current address. So this is done. Now let's try and configure our database part. So for that I'll create a new folder called database. Inside the database folder there'll be a file called mongoose.js. This will configure our database and return the mongoose object. And also inside the database we'll have a models folder. Models will basically map our database schema that we'll create and convert it into collections, and then mongoose will use these models to map our data to the mongoose database and fetch the data and map it into these models. So we'll be creating a list model, list.js, and finally a task model, which is task.js. Now that we've created all of them, let's first configure our database. So for that we need the mongoose library. We'll import it and assign it to a variable named mongoose. So after getting a reference to the mongoose library, we can simply connect to it using the connect method. Before connecting, we need to assign mongoose.promise to the global promise. This allows us to use promises in order to handle asynchronous code, that is code that could take a long while to complete. So when we're connecting to a database, it could be that the database takes a lot of time to connect and we don't want our application to freeze until the database connects. So we pass in the URL of our MongoDB database. Since we're using a local database, all we'll do, we'll provide a local address, which is 127.0.0.1. Remember that it's not neither HTTP nor HTTPS. It's a custom protocol called MongoDB. And inside that, after the / you pass in the name of the database. I'm calling mine task manager. Now this is where the promises come. Since we're using promise, we can use the then method, which will encapsulate the code that we need to run when the database is connected. So when the database gets connected, we want to log it so that we have some indication that the database is running perfectly. So one other thing, 27071. This is the port that MongoDB uses by default. So we will console.log database connected. And if there is an error, we can console log the error that we get back. And now what we need to do is we need to export this. So for that we need to use module.exports is equals to mongoose. And finally we need to import it to our app.js. App.js is the entry point of our application. So we go const mongoose is equals to require. So inside the current directory, go to the database folder and require the mongoose folder. Now we need to rerun our server. And as you can see, the server is connected. Okay, we are getting an error here that says it's not network error. Okay guys, so the error is that we have incorrectly named the port. So the port should be 27017. Now if we run it again, as you can see, the server is connected on port 3000 and the database is connected as well. So our application is running, but we're getting these deprecation warnings. So these warnings basically means that in the future version of Mongoose, since we're getting these deprecation warnings from Mongoose, we can say that in the future version of Mongoose, they will have some configuration options that you need to pass in. So if you wish to upgrade to the future version of Mongoose in any near future, you need to pass in these options. So the first option is use new URL parser and the second option is use unified topology. Both of them are set to true. So we can do that simply by going to the connect method and pass in the configuration option. So we'll be passing the use new URL parser to be true and then use unified topology to be true as well. Now whenever we make changes to our application, we need to rerun our server. And it's working, and now we're getting no deprecation warnings. However, as you can see that creating changes into our application to fix any error or any warning and then rerunning the server is a little cumbersome and difficult, and this could slow us down. So we can install another package globally, that is what the -g flag is used for. It's called nodemon, and when we do this, it'll take some time, but it'll install pretty quickly. It's a small package and it'll do exactly what we need it to do. It will restart our server whenever we make changes to any of the files in our application. So after doing that, we can just go nodemon app.js, and as you can see, our application is running. Now let's see if it's working. Server is connected, and now if I save it, as you can see, the server is restarted automatically because of the changes made, and it's working correctly. So now let us begin by understanding how to set up our application. The first thing that we need to do in our application is we need to enable our application to be able to parse JSON data, which is the format in which the data will be exchanged between our front end and the back end. So to do that, it's quite simple. Just type app.use express.json, and this will allow our application to use JSON data. Now, if you have worked with the previous version of Express or have seen tutorials, they will be using something called a body parser library, which does exactly the same thing. But since it's so common that everyone used it, the Express team, or the team that built the ExpressJS framework, they have incorporated it into the framework itself. So you don't need to install another library to use it. And finally, what we need to do is to enable CORS. Now, a brief introduction to CORS. CORS means cross origin. CORS, CORS means cross origin request security. So what it basically means is, since our application will be running on port 3000, even though the domain is the same, localhost port 3000, which is backend API, and our front end will be running on localhost port 4200. Now these ports can be configured, but since both of them are not going to be running on the same port, what we need to do is the front end. Now, since they are both on different ports, Express will take a look at the request that comes from any port other than 3000 and reject it as being unsafe or as being unauthorized. So to prevent this from happening, we need to enable CORS, or CORS. So for that, we type this code. You can find this on internet as well. It's quite simple, and I'll explain it. So this is app.use. Use allows us to create a middleware, which, as we have seen in our slides, is used to create functions that check requests and response objects. So in this, we are setting some response headers, which is access control allow origin, access control allow methods, and access control allow headers. So when we add these headers, it allows any origin to be able to access our API, allow any of these methods ranging from get, post, head, options, put, patch, delete to access our API, and finally we allow it with all the headers. So after doing this, we call the next, which is the next middleware that is passed into it, and this allows application from other origins to be able to access our API. Now there is another way of doing this. You can just install a package called CORS, CORS, and then just use app.use on this and it'll do exactly the same. But since it's such a common task, people have extracted it out of CORS library, and it's exactly what that library does. So after doing this, let's see if our application is still working, and it is. So let's begin. So let us now move on to building our models. So as we can see, we have two models, list and tasks. So we'll build both of them. First, we'll build the list model. So to build the list model, let's first require mongoose. So after requiring mongoose, what we need to do first is we need to create a schema. So for that, we'll need to create a schema, which is const list schema is equals to new mongoose.schema. This takes in an object that is the definition of our schema. So what we need is we need a title. This title will have a type, which is the data type of string. Now we can add additional attributes to show you. Minimum length of the title should be 3, so it should be at least 3 characters long. And finally, we can enable trim. So trim would be if the title is added as ABC and with 10 spaces at the end and 10 spaces at the beginning, those spaces will be trimmed out or removed. So trim is equals to true. So this is all we need to do to create a schema. Now we need to create a model. So list is equals to mongoose.model, and it will take in a schema and the name of the model. So the name of the model is list, which will be the name of the collection inside our database, and the name of the schema that we just created is list schema. Now all we need to do is export it. So module.exports equals to list, which is this is the list, which is the model. Now we can create tasks. So to create the task model, we'll need to do exactly the same thing. So we can just copy it from here, just paste it here. Instead of list schema, we have task schema. It will have a title. Another thing that it will have, which is important, is a list ID, which will be the ID of a list. So each task will be associated with a list. So if we wish to create a list named shopping list, and then we can add the tasks inside that list will have those tasks will have the list ID as the ID of shopping list. So let's create that. This will have a type of mongoose.types.object ID, and this is required, and that's it. Required would mean that no task inside the tasks collection could exist without a list ID. And finally, we need a property that will show us if the task has been completed. So the type would be boolean. Boolean only contains two types, true or false. True would mean that it has been completed, and false would mean that it hasn't been completed. And finally, we can make required as true, and also we can add default as false. So when the task is first added to our database, it's created as not completed or false completed. And finally, we need to create the model and then export it. So const task is equals to mongoose.model. Name of the model would be task, and the schema as we just created, task schema, and then we can export it using module.exports. Make sure to export task and not task schema. Task is the model, task schema is just the schema. Now these are the schemas that we're using, and these will enforce certain constraints on the data that is stored into our MongoDB database. So right now building our models is done. Now what we can do is we can import them inside our app.js. So we can import list, databases, models, and list. Similarly, we can import task as well, and it's done. Now we need to create the routes, the URL endpoints that our application will request data from. So let's think about this. So the URL endpoints that we need to create should have the following tasks be done: list and task. We need to be able to create a list, update a list, read, which is to get data from the list or get data about the list, and read one. You can split it into read one and read all. This will return one list with a specified ID, and this will return all the lists that are in our list collection. And finally, we need to be able to delete the lists, and we need to be able to do something similar here as well. So how we want our URL schemes to look, we'll create a RESTful API. This will allow us to create URL patterns that match the RESTful standard. So these are the tasks that we need to perform in our application. We need to be able to create a task, update a task, read one task, read all tasks, and delete a task. Similarly, we do the same things with the list as well. So let's begin by creating each of these URL endpoints and use our models to save the data inside the database. So let's begin. So let us begin by creating our lists, or all the routes that are related to our lists. So first we'll create a route that will help us get all the lists that are stored inside our list collection. So for that we use the app variable, and it has a get method. Inside the get method we'll add slash, which would translate to http:// localhost:3000 / and actually we have to convert it to /lists. So we'll send a get request to /lists, and this will end up returning us an array of all the list items that are inside our application, inside our database. So to do this, firstly we'll define the route. Now first thing to notice is that we have several methods. So we have get, post, put, patch, delete. So these are HTTP methods that allow us to check if these are the HTTP methods that are related to specific tasks. So when we send a get request, this corresponds. A get request means we wish to get some data from the database, so get data. Post request means we want the server to save some data that will pass in as a parameter. Put and patch requests are used to update a specific row or a specific document in our collection, and the delete method is used to, as the name suggests, delete a document. So we'll be using these methods to perform these tasks. So the first thing we need to do is we need to define a route to get all the lists inside our list collection. So a get request to this URI, and we'll be using arrow functions. Inside this we'll get the request and the response. And what we need to do now is we use the task model. And we pass in an empty object, which means that we want all the records in the database. After finding it, we use the then method, because Mongoose is using promises. We get all the lists. We response.send all of those lists. These will be in JSON format. So like I said, JSON format is good for exchanging data between the client and the server. So after that, all we need to do is we need to catch any errors if they occur. So right now we are doing very simple error handling. We can just console log the error. If there are no errors, then it will send the response back to the user. So let's see if this works. First of all, let's open the terminal and see if it's working correctly. This is our terminal, and let's start the server. So cd into backend, and then node mon, and the server will be using is in app.js. Start it. The database is connected, the server is connected. Now to check whether our API is working correctly or not, we'll be using a REST client. It's called Insomnia. It's free, so you can download it as well and use to follow along. So after Insomnia loads up, we'll create a new folder that will contain all the requests that we need. This will be called Task Manager. Inside Task Manager we'll have two folders. First will be for lists. So all the requests related to the list collection are put inside this, and inside task manager another one would be tasks. So these are the two folders, and inside lists we'll create the request. It will be of get method. As you can see there, I get, post, put, patch, delete, options, and head. We use get, create, and type in the name of the URL. So this is our local server. We're using port 3000, and we have defined lists. Since there are no data in our collections or no lists in our list collection, we're getting an empty response. However, if we look into the headers, we can see the request was passed correctly. And we have gotten a 200 OK response, which means everything went fine, as you can see here as well. Now let's create a route for the user to be able to store a list. So we create a post route. Remember, post is used so that the user can enter some data into our database. So the post request will contain request response. Now what we can do is we can use the task model again. Task dot, I think it's create, create, and let's enter what we wish for it to create. We want lists title to be equal to request dot body dot title. We can create new task with this, and here. And then we use the then method dot save. This will save this task. We use the then method. We will get the list back, and we will send it back to the user. And if there are any errors, we'll just console log them. So instead of writing it again, I'll just copy it, and that's it. So as you can see, our server is still running, which means we haven't made any syntactical errors. Now we will create another request. This one would be to save lists. This would be a post request, and the body you can choose to be JSON, because this would be the format in which we'll be sending the data. So it would be title, or you can type list 1. Now we can give the HTTP URL localhost :3000/lsts, and as you can see, here we have to type list lists, and when we send it, we are getting an error. This is title of undefined, cannot read property title of undefined. Okay, so let's see what's going on. So I think the issue is with our application here. Oh yeah, we have registered the JSON parser right below. We need to do it at the top, and yeah, it's working fine. Let's try this again. Okay, we are taking a lot of time. Let's see, something's wrong here. Okay, let's see. In our code, we are getting this error. It says list ID validation error, list ID. Oh, okay, I see what the error we have made, and we have made this error previously as well. So the issue here is we are saving lists. We shouldn't be writing task, we should be writing list. So new, sorry about that, and let me just indent it so we see if it's working properly. So let's see again. Does this work? Okay, so the list is created, and if I get all lists, I should get one. Yeah. So if I wish to create another list, I can just type list2, send the response. We're getting the response back as the second list. This is the ID of the list, and now we're getting all the lists that are in our list collection. So let's move on to the next topic. First of all, we'll minimize this console. So we have created a single list. We have saved the data inside the list. So create is done. Read one, we need to do read all is done. So now we can app.get will be dealing with the read one part. So lists/list ID. This is a parameter that will be passed in the URL. So the URL will be something like localhost :3000 localhost:3000/lists list/ and the list ID would be one of the IDs, so it could be this one. paste it here, and if this is the request we get, then we'll return the list with this ID. So the way to do it is again callback, which will accept the request and response, and then we list.find where underscore ID, as you can see this is the parameter that we're searching by, is equal to request.params.list_id. This name should match the name that we have described here. Okay, and after finding it, we will just copy and paste this code. Let's see if, yeah, okay, no error so far. So let's try it again. Create a new request, call it get one list. It will be a get request. So this is the ID that we want to get. We got http localhost 3000 / the ID / list / ID, sorry, list / list ID, and we send it, and as you can see we get the output here. So it's working correctly. So we have completed 3 of the 5 things. So we have created API endpoints for creating a list. We have created an API endpoint for reading all the items in the list collection, reading one list, and now we need to perform update and delete. So let's see how to do that. Now for update and delete, we need to use instead of using get and post, we'll be using put or patch, whichever one you wish to use. Put is used for updating the entire collection or the entire document that we need to update, and patch is used to just update one single field in that. So if you want to strictly follow the REST guide or the REST specification, then you need to use patch here. So we'll be using that app.patch. Inside it we are giving this, and we are getting request, we're getting response. Now what we need to do, we need to get list.find one and update, and it will take 2 arguments. So the first thing would be, as we saw in the update query that we made in our MongoDB shell demo, here we'll pass the ID. So underscore ID would be equal to request. First thing I need to change is this request.params.list_id. Now list model has just one title property, so if we're updating it, we're only going to be changing that. So when we get this, what we need is another document in which the $set property is set to request.body. Now we do this, so in the body we'll pass the title and it'll update automatically. We won't have to manually assign each of the fields one by one. After doing this, then we do the then, and we'll return the list. This is updated, and catch the errors if we need to. So let's just indent this properly, save it. Let's see if there are any errors. There aren't. And let's see, let's create another request. This would be a patch request. We will update list, save it. The body that we need is JSON. This is the URL that we'll be looking at. Patch would be the method, and we type the updated. So the title needs to be updated title. Now we send it, and we get back the response that says type list2. So let's see, I think we've made a mistake. So let's see what's the matter here. So the problem, I think, as far as I can see, okay, yeah. So there's another parameter that we need to change, which is use find and modify and set it to false. So for that we need to go to our mongoose file, and here we'll use find and modify and set it to false. Save it. It's still working. Go to here, and as you can see, we have updated our title. So there are some deprecations, so we need to make sure that we are following the current standard set by the mongoose ODM, and it will work perfectly as it did just now. Now finally, what we need to do is we need to create the routes for deleting a list, and to do that, all you need to do is whatever we've done so far. We go app delete request would be a delete request, that will come to /lists/:list id. We pass in a callback with request response, and similarly as we've done previously, list dot find one and delete. I think the one we are looking for, find by id and delete, or find one and delete, whichever one you wish to use. You can go find one and delete or find by id and delete. I'll use find by id and delete because we are using the id to find it, like the one we mentioned so far. So as you can see, we can pass in the id and the id will be okay. So the id is passed. We can simply pass the id, I think. So request dot params dot list id, and after doing that we go then, and it's the same. So I think it will return the list. You can either pass return the list back, or you can return a response code of 200. I'll show you both. So let's see if it's working. It's working. Now let's go to Insomnia and create our request. Delete the list. It will be a delete request. Create, and all we need to do after we get all the lists, these are the list IDs. Let's say I want to delete the list with the list number as 1. So the title is list 1. After I delete it, you won't be getting this one back. So go to the URL http://localhost:3000/lists/ and the ID is this one. Let's see, the ID is correct, lists/list ID, yes. So after this, the method is delete. Let's see, so it sends us back this list and the response code is 200. okay, so I think it worked perfectly. Let's see if we get all the lists, if this list deleted, and yes it is. So our list routes are done. We have defined all the URL endpoints that our application will respond to, corresponding to the methods there or the functionality that we want for the lists in our database. Now we need to create for tasks. Now to create all of these same things for tasks, one thing that we need to make sure is that we understand how our URLs will be made. So since each task is associated with the list ID, what we want is a URL scheme that looks something like this: localhost:3000/lists/list ID/tasks/task ID. Now each task is associated with the list. So if a list contains a task, then the URL will be the lists/the list ID, and then the task that we wish to get, and the task ID if we wish to get a single task, similarly as we have done here. So this is the URL that we'll be building to create our lists. So for that we can just go app.get, and this time, since it's this URL, I can just copy it from here. And now what we can do is a callback. So request response. Let's see how it's working. So is it working fine? Yes, it is. So now we'll use the task model. So we use the task model, and task.find is the method that we'll be using, and we want to get all the tasks that have, that have this list ID. So let's see, we'll be passing in _list ID. The reason where we're passing _list ID is because inside the task we have defined a property called _list ID, which is of type mongoose.types object ID, which will be referencing or storing the list ID of a list. So the same way that we got the list ID is request.params. and it was list ID, so to avoid mistakes, and then we find all the lists with this list ID, and then we send it back. To send it back, all we need to do is just accept it as the parameter, or we can just copy and paste it. It doesn't really matter. Just make sure that you're using the task model instead of the list model. We'll be changing that here. So instead of it being called lists, we can call it tasks. As you can see, it's working. Now if I were to use this URL, it should return an empty array like it did previously. So inside the tasks, create get all tasks, which is get request. This is the URL. Now we need to make sure that the list ID is correct. So for that we go to get all lists. This is the list ID. We go to the tasks. List ID is removed, replaced with the list ID that is in the database. We send the request and we get a 404, which means that we have not registered our route correctly. Either we have not saved it or it's not working properly. So let's see. Okay, save it. And it's localhost. Oh, sorry. Yeah. So we don't have to pass in the domain, the base URL, which is the local HTTP localhost. We just need to pass this. Let's see if it's working properly. Yes, it is. Let's try this again, and we are returning an empty array, which is exactly what we wanted. Now let's just rename this for a second so that we can get and now we'll try to save a task. So to save a task, we simply need to replicate this behavior. Instead of get, we will use the post method. Post method will have the same URL, but instead of us finding a task, we will be creating one. So for that we need to create new task. Inside the task we will pass in an object. That object will have similar structure to the task. It has a title and a list ID and completed. So completed is by default set to false. So we can remove this if we want to and just pass in the title. So we will pass the title as request.body.title. This will be passed through our JSON request, and we will pass the underscore list ID property as the request.params.list ID. So as you can see, we are getting the list ID from the URL and we are getting the body from the title. After passing this, let me wrap it inside block. We can do a save first. After saving it, so we get the list, we get the task back, and what we need to do now is just response.send the task, and if there's any error, then we can just catch the error and then display it in our console.log error. I'm not sure if I've typed this correctly. Yes, it's working fine now. And is it working fine? Yes. So let's see if it's working the way we expect it to. Create a new request, save task, make it a post request. We'll be making this request to the same URL, changing the method to post, and the body is going to be just title. We can call it task1. You can call it anything you wish to, but for our purposes task1 works fine. Send the request, and it's taking some time, which means something has went wrong. New task, then we use the save method, providing it with the list ID. Oh, request.params. Sorry about this. And now it should work. Yeah, so since the completed was set as default as false, we're getting false. The ID is generated automatically. This is the list ID, and this is the title of the task that we created. And now if we go to get all tasks, we get one task. Let's create another one in the same list, call it task2, and lastly create another one, task3. Now if we get to get all tasks, we should get 3 tasks, and we do, and all of them are false. Okay, so it's working fine for now. Okay, now let's go to we have gotten all the tasks, we have saved the tasks. Now we need to get one task, so it would be similar to this. Just copy it, paste it. We get lists, list ID, tasks, and task ID, and we get the list ID is this. Inside the list ID, the task ID, which is underscore ID, should be equal to request.params.task ID. So task ID, and since we're returning single task, instead of calling it tasks, we can call it task. See, So it's working correctly. It's a get request to this. It's request.response, and we're getting the task which has the list ID as the list ID passed in the request, and the task ID as task ID passed in the request. And we get okay. So it should work. Let's see if it's work. So we create another request, get one task. It should be a get request. It's going to be the same URL, just the task ID is required, and we'll pass the task ID. After we getting all the tasks, copy this, paste it here, get request and send it. Oh, and we're getting our task. So it's working fine. Maybe what we can do is find one. Let's see if it's working, because it's returning an array and what we need is just a single task. Yes, it's working fine. So we have done 3 out of the 5 for tasks, and now the 2 remaining ones we'll be doing right now. So let's do the update one. So what we can do is we can get all the tasks. Okay, so what we need to do, we need to update. So we need to check the method. If it's a patch method, on this we need to find one and update, which is this one. So we need to find the ID, we need to find the task with this list ID and this task ID, and then what we need to do is we need to use the $set parameter to request.body. So all the parameters that are passed into our request's body, they will replace the body of the document that has the list ID as specified in the URL and the task ID as specified in the URL. After that, we'll get back the updated task, and if there's an error, we'll get an error. If it's working correctly, let's see. Create a new task, call it update task. It's a patch request. It would be the same as this one. So the list ID is here, task ID is here, the body needs to be JSON, and the title would be updated. Let's see if it works. Send the request and we get task 1. Okay, let's see what the error is. There's no error. So why we're getting the same task? Updated task. The title is task 1. We are passing the title as task 1 as updated task. Okay, so it's updating the task and it's returning the previous task. Okay, let's see. New task. Yeah, so the task is being updated. Let's see new sample task. Send the request. So and we get all tasks. A new sample task is here. So okay, so it's being updated. We're just getting the document that is being updated, not the one that gets updated. So this works as well. Now let's see what other things we need to do. Now just the delete part is required, which we can do quite easily. Delete lists, list ID, tasks, task ID, find one and delete. Now deleting. Okay, so we are going to be finding one and deleting. Where list ID is request params list ID, task ID is request params task ID. So then it's the same thing. Let's see. We'll be deleting this one, creating a new request type called delete tasks. It should be of delete method. We paste, we send the request, we have deleted the task, and now if we get all the tasks, they should be deleted. There should only be 2 tasks, and there are. So our API is complete, I think. Let me just check. This is the tasks. Let me write it down so that we can task URL, and this is the one for list URL. So tasks with lists. Okay, and one more thing I just realized. When we are deleting the list, do we need to delete all the tasks associated with it? Now this is certainly up to your criteria. So if you don't wish to delete all the tasks, you want the tasks to remain in the database, and you just wish to delete the list, you can do that. However, we are going to delete all the tasks related to that list as well. So let's see how to do that. What I'm thinking is I'll create a new function. Inside this function, that will delete all the tasks. It will take in the list that was just deleted. Sorry. And simply just take the task. Delete many would be the one we'll use, and the condition would be where the list id underscore list id is equal to the list that was that id of the list that was currently deleted. After deleting this, we will return the list. So sorry, this is the list that will be returned to the user, indicating that the list that was deleted is the one that we're returning back. And similarly, if there are any errors, that will catch those errors and console.log them. Now, since we have declared a function but we haven't used it, so let's use them. So delete tasks, we'll pass in the list, and finally const, and what we're getting back is the list is equals to this, and we'll be response.send the list that we get back. And I think this should work unless I made some mistake. No, it's working correctly. So let's try it out in Insomnia. So let's see. I'll create a new list to see if it's working properly. So to do that, I create save lists, list delete, send it, the list is created. This is the list ID. Now I'll create some tasks here. So when I go get all tasks, pass in the list ID, send. There are no tasks right now. Let's save them tasks. delete my list, send 3 times, and when we get oh sorry, I think I forgot to pass the list ID. Yep, 2 3, and then we send it. We have delete my lists. So these are the 3 tasks that will be deleted when we delete the list with this ID. So we go to delete list. This is the list that we want to delete, and I hope it works. Let's see. So we're getting back an empty response, but let's see if the task is working. So these are the tasks that we got previously, and yeah, so the tasks are being deleted. So that's working perfectly. So instead of returning the list that we have deleted, what we can do is we can just return response.status 200.send, and that's it. So it's working properly. So our API part is complete. We have created the API. Let's do something here. So instead of doing it this way, we can response.send. So it's let's see if this works out fine for us. Okay, and we'll do the same thing. We'll first create a list. So we go save lists, list delete. This is the ID. Copy it, save tasks, send the ID, delete my list, delete my list, delete my list, get all tasks of this list. It has 3 tasks. Now we'll delete this list. Hopefully this will return back the list. No body is returned. Oh, okay. The mistake here is that, yeah, fine. So okay, so it's fine, it's working. We are getting a response code of 200, which means that everything went perfectly. Now if I get all tasks for the list, I get an empty list, and if I get all lists, the list that we wanted to delete is not here. So our API is complete. This is our complete backend working, and we were able to create it in JavaScript by using Mongoose and Express, and we are allowing certain codes and using the JSON parser. So now let's move on and build the front end using Angular. So now that we're done with the back end of our application, we'll create the front end. Now let me close this. To use the front end, firstly make sure that your back end is running. So our backend server is running in the background. We'll create a new terminal, and inside this terminal, firstly we'll need to install the Angular CLI. Remember, the Angular CLI, as we've discussed before, is a command line utility that allows us to create new Angular applications and components for Angular applications, such as services, components, modules, so on and so forth. So to do that, we need to do npm install -g because we need to install it globally. Then go angular/cli. This is the name of the package. We press enter. I think I've already installed it, and even if I haven't, it'll work just fine. So it'll take some time because Angular CLI is a big package. Let's see, it's checking the version. So it's extracting it, installing it. Okay, so it's installing it. After it's installed, then we'll need to generate a new project using the Angular CLI, and we'll do that inside the front-end folder because we've already created a front-end folder. We just need to cd into that folder and then create a new project. This will generate all the project files that we need. So if it asks, would you like to share anonymous usage data, you can either choose yes or no. I'm going to choose no. And so you can see Angular CLI is installed. The current version of the Angular CLI is 8.3.15 as of the time of this recording. So let's clear this, go into front end and check if Angular CLI is installed correctly. Type ng-version. This means that our Angular CLI is installed properly. This is the Angular CLI. If you get the response that ng is not a recognized internal or external command, that means there was some error installing your Angular CLI. Now you can generate the new project. So we go ng create. Oh, I'm sorry, it's not create, it's ng new. Then the name of the application, we have named it front end. And then we'll be passing in directory. Now if you don't pass this directory flag, it will create a new folder named frontend and then create all the files for your project inside that folder. Since we have already created the frontend and we are inside that frontend folder, we don't need to create another folder named frontend. So we are passing the name of the directory as the current directory. Now I think if we press enter, this will create. Now if it asks whether you would like Angular routing, you should choose yes. And then when it asks for you to specify what kind of CSS would you like, well, we'd like SCSS. You can use CSS, Sass, less, stylus, anything you like. I'm going to use SCSS for this tutorial. So the files are created. Now it's installing the node modules, the required dependencies for our application. This will also take some time. So if your net connection is slow, this may as well take around 10 to 15 minutes. So just wait for it to finish. If you've performed this before, then it might be a little faster since some of the packages might be cached, but it could take a lot of time depending on whether you're running it for the first time or the second time or the third time. As you can see, it's generated the node modules folder. It's extracting all the modules inside that. And as you can see, it's been installed. So it added 1188 packages. And because of this, we're now getting all of the things that we need. So this is the folder structure. We have an E2E src directories. Most of the code that we'll write will be in the src directory. Src stands for source. It has an app directory, assets, environments, and main.ts, polyfill.ts, test.ts, and so on and so forth. Now as you can see that the files are having the extension of .ts. So .ts stands for TypeScript. As we have seen earlier, that JavaScript is a weakly typed or dynamically typed language. That is, it doesn't allow us to write code that expects any types. So to overcome its weakly typed, overcome the problems that we face because of it being weakly typed, we use TypeScript. TypeScript is created by Microsoft. So TypeScript allows us to write code with types. So for instance, in this we have a routes property that is of type routes, that is an Angular type, and it's currently set to an empty array. And we can create our own types as well, but for right now it's working like this and it's working fine. So let's begin by checking if our app works. To start our application, go to the folder in which the application is installed and type the command ng-serve. Press enter. Now this will take some time, but it will spin up a server that will be serving our front-end application, and it will be the boilerplate code that you get at the beginning. So this is what it looks like. It's saying it's compiled successfully and localhost 4200. So you open that up and you get this. This is the page that you should be getting, and it's also showing you how you can generate a new component and how you can do something else as well. So let's begin by just first checking if we can make changes into the application. So go to your code, and as you can see, the only thing that we have right now is the app component, app.component.typescript or .ts. Both are the same thing. So inside the app, we have the title set as front end. Let's change it to, and by the way, front end is the name of the application that we created. That's why it's called front end. Let's call it to task manager. We save it, it will automatically recompile as soon as we save it, and we get this task manager app is running. As you can see that this is updated automatically. We don't have to make any changes right now. So if I check task manager change and I save it, as you can see the browser updates automatically and the changes are reflected in our website or in our web applications front end. Now that that is done, let's move on and see what we can do. So I think the first thing we'll need to do is we need to add some styles and change the default index.html. So let's open index.html. This is the file. As you can see, it's app-root. This is the selector that will be displaying the HTML content of our app component. And the way we get it is we look at app component.ts. As you can see, the selector is described to be app root. So now whenever in HTML it says a tag that's named app-root, it will replace the content with the one that is described in app.component.html, which is here. And this is the component. This is the default component and the default styles. So we can delete all of that completely. Just make sure you don't remove the router outlet. And if you do, then you need to recreate it. We'll see what it means, what this router outlet does. But firstly, let's just save it and see what the effect is. So as you can see, we are getting a blank page right now. It's fair enough. So let's see how to work with Angular applications and create our front end. So the first thing that we'll need is we'll need to install Bootstrap for our styling. Now styling would be pretty much done fairly quickly in this session because it's more about JavaScript than it is about CSS. But to get some good base for our styling, we need to install the Bootstrap CSS framework, or you can use the Bootstrap SCSS framework since we are using the SCSS extension. So we'll need to firstly install Bootstrap SCSS. So to do that, firstly we'll need to open the terminal, create a new terminal, and then what we need to do is, so we need to type in npm install and bootstrap-scss. This will install the bootstrap-scss package into our node modules folder. We press enter and it starts and it's done. So the bootstrap folder is installed. I think it's here. You will see it in boot bootstrap. We'll look into that. So the first thing that we need to do is we need to open our front ends, styles.scss, and here what we need to do is, oh okay, I see the error. So we have installed Bootstrap in our main stack project folder when we needed to install it in our front end folder. So that's easy enough to rectify. We need to first delete this folder, node modules. Delete this. We can remove the package.json file from here as well. Now we need to cd into front end, and then we can install bootstrap-scss. So it's installing in the correct folder right now, and yeah, so it's installed. Now let's see if it's installed correctly or have we made a mistake again. Bootstrap-scss would be at bootstrap. Yeah, so this is installed. So now what we need to import the bootstrap.scss file. So in our styles.scss we go @import and we give it the path. So inside our node modules folder, bootstrap.scss, install the bootstrap.scss. That way it will be installed and used in our application. So if we look, is our application running? Yes, it is running. So if we open our front end, so nothing's changed so far. But if we look at the page source, we have all of this Now let's see if we can do it. So let's first collapse all of this. Now that is done, let's create a new folder inside a new file called main.scss. This will contain all of the styles that we'll need for our tutorial. So for that, what we need to do is, so these are all the styles that our application will need. I am simply copying and pasting it because these styles are very easy to understand and they are quite difficult to use. So they're quite easy to mess up as well because there's a lot of text. So instead of me having to write it completely and then messing it up, I've just pasted it. Now I'll explain it step by step. So here we are importing two Google fonts named Nunito and Lato. Now fonts, you can, if you wish to, import whatever font that you feel comfortable with. These are the ones that I have chosen. If you wish to know how to import fonts using Google Fonts, just go to Google Fonts website and it's running. After you've done that, then you can just search for the fonts. We'll be using, first one is Nunito. We'll be using the 400 and the 700 one. So add the 400 one, then we add the 700 one. Similarly, we'll be using Lato. So we go Lato, add 400, then 700. We add that as well. And now that we have done that, what we can do is we just need to copy the import statement. So we can just copy this and then paste it inside our SCSS file. But right now I've already done that, so I'm not going to do that again. And as you can see, our application is running. No errors are thrown so far. Let me save it first, and I hope it's running. Let's see if it's running properly, and it is. Okay, so now what we need to do is we need to import the main.scss file into our styles file so that this can be picked up. So we write @import, and inside our styles file we'll be importing main.scss. Forget to use the semicolon, and it's compiling successfully, so it's working fine. And this is the gradient that we're getting because our styles are applied now, and we'll be building our application moving forward with this. So far we have imported the Bootstrap SCSS framework. We have created our own styles. Now we have imported our desired fonts as well. Now let's begin by firstly generating a new component. So for that we'll use the Angular CLI. So let us begin by creating a task view component. Now make sure that you are in the front end directory, and let's see what we have. So we look at the directory tree. We have all of these directories and files. We need to cd into our src directory, and as you can see, inside the src directory we have app, assets, so on and so forth. We cd into our app directory, and here we'll generate a new component. So we go ng generate component, and the name of the component would be pages/task. Now the reason why I'm giving pages/task list is because I want there to be a separate folder for all the components that I generate, and the folder's name should be pages, and whatever I type after pages/ would be the name of the component that I'm generating. So we can call it task list, but let's call it task view. So we have component pages/task view. Now if I press enter, so as you can see, it's created a new folder called pages inside the app directory. Inside that there is component with the HTML, the CSS, the types, the JavaScript file as well. So let's open and see what it is. So the task view component is nothing but an empty component, and the HTML page will have just a paragraph tag that says task view works. But as you can see, it's not going to work in our directory right now. As you can see, our application is not picking up anything. So to make it work, we need to create a root. And to create a root, we need to open the routing module. So when you scroll down, I think inside app directory, app-routing.module.ts, and this is where we will create new routes. So inside the routes we first enter the path that we want. So for the root path, we create an empty string, and then we type the name of the component that we want to use. we have created a task view component, and because we are using Visual Studio Code, it will automatically import the task view component. Here's the task view component, and here's the task view component imported and registered with the root. So now if we open, we can see task view works. Now the reason that this is working is because when you go into the app component, there is a tag called router outlet. Angular looks at this tag, and any route, any component that we are routing to, its HTML content will be displayed inside this router outlet. So what happens is the request flows through the index.html page, which is here. It looks at the app root. App root is the app.component.html. So we go to app.component.html. It looks at the router outlet, and then it looks at the current route. The current route is, well, it's empty, so it's an empty string, and since we have registered an empty string to display a task view component, it takes the task view component and then displays it here. Then this gets displayed here inside the body tag, and when we look at the HTML, as you can see, inside the body tag we have an app root, and when we inspect it, we can see that this is a p tag with the task view works inside the app task view just underneath the router outlet. So our application is working as we expected it to work. Now let's see what's going on. Let's see what we can do to make our application look better. So that this is done, I think the first thing that we need to do now is create the HTML for our task view. But before we make the HTML work, we need to first look at the CSS. So what we can do is we can open the app pages task view component, and inside that we can paste the CSS that we have, and we save it. Now this CSS is basically just we use the flexbox container. Inside that we create a margin with the width and height, and the maximum width and maximum height is displayed. Then we again use flex, we use the direction, width, height, and these are all very simple styles. We're using SCSS, so we can nest these styles inside one another to get better and more concise syntax. After that, let's tackle the HTML. So instead of having this, first let's save this. So we can create a div with the class centered content. Inside it, we'll create another div with a task manager container class, and inside it will create another one with class for a sidebar. Now inside the sidebar we'll have an h1, and that h1 will have a class of title and has text. This will give it the necessary styling, and then let's call it lists, save it, and let's see. Yeah, so this is the sidebar that we want. It's showing up nicely. Now let's move on. Now underneath that, what we can do is we can create another div with a class of list menu, and inside that we'll create a link with the list menu item class. Now the href we can just put a pound there for right now, and inside it let's type something. So let's say list 1. We save it, and then we look at the content, and we are getting the list 1. So it's working fine. As you can see, it's a little muted right now. So if you want to correct it and show the list that's selected right now, let's do it this way. So we can add a class of isActive, I think. Save that, and now as you can see, the list 1 is selected. So this is all fine, but what we want to do is we need to get the data from the server and then display it into our list. Now this is a little tricky, but to do that, firstly we'll need to complete our markup, and then we'll jump into the JavaScript code that does this. So let's go back to our file. So to make it look a little nicer, we'll have a p tag with a class of white text, and it will be inside this p tag. Inside the p tag we'll have a span tag, and that span tag we'll have a class of task delete. We also have a class of pull right. These are all the tasks that we have implemented, and we can take a look if it's and we put x. X would be the delete button, what the delete button would look like, and this is what it looks like right now, the white text with the muted background and the delete tasks. And let's jump into the code and see what else can we do. So let's add another class inside the span of btn rounded. Save that, and now let's add another button, which would be, I think, inside that list menu. So we will add a button with the class of btn primary, btn rounded corners, add list. Save that, open it up, and it says add list. So whenever we want to add a new list, we click on this button and we get to add a new list. So it's working fine right now. Let's move on to what we can do next. Our button looks fine, but we need to move it a little downward. Then when we save it, it's outside the container right now, but we can fix that pretty easily. So essentially we went a little too far. We need to push it down here, and now when we see, so our list is working fine. This is where it should look, and this is where it's looking. Now let's move on to the next topic. So let's add some code that has to do something with Angular. So what we can do is we can use a structural directive called ng4. Now this might break our code right now. Let list for lists, and this will break our code because there is no lists property on our task view component. We can create one if you want to. We can create a lists of type of array of any, and we can set it empty to an empty list. Then what we need to do is, so we have to go let list of lists, which is a for of loop, and here we use these curly braces. Now Angular's compiler will look at the template, look at the curly braces, and will replace the code inside the curly braces with the code that we want to use. So inside the curly brace we can type any valid JavaScript code. Right now we are using list, so let's see, list.item or list.title, sorry. Save that, and it will not work right now. I think it will show us an error. Okay, so it's not showing us an error because there is no item in the list. So if we fetch the records from the database, then we'll get what we need. So for that, what we need to do is we need to firstly we'll complete the markup, and then we'll move on to JavaScript. Now that we have displayed our lists, we need to display the tasks. Now displaying the tasks is quite similar. We can copy this. So this code would be the same. Copy that, and so what we can do is we just copy this one because we have a list of tasks. Then we go down, we have the buttons, and now we have the task manager container. So inside the container, what we need to do is we need to create a task, a div with a class. Let's see, the class should be, so we need to have a div with the class of task. Inside that we have an a, which is a link. We don't need that. Save that, and this would be a problem because we are referencing a list right now. Let's name it task right now. Let's see if it's working, and it's working. There are still some issues. We'll fix that. I think the problem is with the markup. Let's just move this a little bit, and let's see if it's working. Okay, so again so what we need to do is we need to take it back a little. Then we need to create a task list container. We need to move our task list inside this, and we need to have same thing as we had before. We need to have an h1 with the class, and we need to type tasks. Now when we look at, and it works fine. Now it looks great showing. And one other thing, when we hover over it, it shows us this hover effect. Now if we were to mark it completed, let's do that. So inside our code we'll type task needs to be complete, so we say COMPLETE. We need to do it here. And when I save it, and as you can see, it's strike through, and right now it doesn't matter whether I click or not. So when we complete the task, then this is what it will look like, and if the task is uncompleted, then it will look like what it looked like previously. So now let's begin with creating the JavaScript part of our component. To do that, we need to open our file, the TypeScript file named task view component. Right now we have a list, and this is where services come into play. So we need to generate some services so that they can talk to the web API themselves, instead of us having to write the code to create web APIs. So to create a service, so to generate a component, what we need to do is we need to create a service. So to generate a service, what we need to do is firstly, remove this. Okay, what we need is we need to write the code ng generate. We need to generate a service. The name of the service would be task service. So we can just type task and then we press enter, and as you can see, task.service.ts is created. Now we need to create another service. We'll call it web, and we press enter, and web.service.ts is also created. Now these files, we need to open these files and edit them. So firstly we'll open web.service.ts, web.service.ts, and as you can see, the generated code is right here. It contains a injectable decorator. Now this is the part of code that allows Angular to figure out how to instantiate our service and pass it as parameters and constructors. So we'll see how we use in dependency injection as we use this service in a component, but first we need to create this the code for the service. So for that we need to pass in a root URL. Firstly we'll create a read-only property named root URL. Read-only means something similar to constant, so you cannot modify this URL. Now that this is done, we get the URL. It would be of type string. This is where TypeScript comes into play. Now any URL that's passed into the constructor of this code that is not string, our TypeScript compiler won't compile the code and will get an error. So let's assign this dot root URL to URL. Now in order to be able to use web services, first we need to use the HTTP client module, and to use that we need to go to our applications module and import it. So to import HTTP module, we go import from @Angular common HTTP, and it's from this module we need to import HTTP client module. Now that we imported it, we need to add it to our imports list, and now our application can use the HTTP client module. Whenever we need to use a new module, we need to perform these three steps: import it from the module, import the module from the module file. So this is the file, this is the module that we need to use, and then we enter it into our imports array. After entering it into the imports array, we open the web services file and we create our services. So to use this, what we need to do, now what we can do here is, well, instead of passing it as a service, we can just pass it http://localhost:3000. This is the URL for our API. Now that this is done, instead of passing in this HTTP client, so we need to private HTTP, and now we need to import it. So to do that, we need to import from Angular common HTTP client and private HTTP of type HTTP client. Now we can use this HTTP variable wherever we wish to in our class because it's injected by Angular. So this is what dependency injection means. Let's say public, let's say void get URI string, and we return this dot http dot get root URL, and we'll use template strings for this. So template strings allow us to generate dynamic strings without having to concatenate them. And then what we can do is we can pass in an @ symbol and the URI that we wish to use. So URI, and let's see. So I think we can. So this is working. So instead of us having to open as this dot http equals new HTTP client and then pass in all the parameters that it has, instead of us doing that, we can just instruct Angular that we need an instance of the HTTP client, and it will generate a new instance and then pass it into the constructor. And this way we can have a property on this class named HTTP which we can access like this. Now let's just create all of our methods. So get post will also have a payload of type object which will contain all the information that our API will need to create a new record in the database or a new document in the collection. We have a put request which is very similar. It will also have a payload of type object, get post put, and in the delete you just have the URI. That's fine. So this should work. We have a problem here. We need to write the semicolon. Now that this is done, we go to our task service, and this is here. Now before we use task service, we also need to do one thing. We need to create a new folder called models. Inside the models folder, we'll create file list.ts. TS stands for TypeScript, and task.ts. Now that we have done that, we'll define the structure of our objects that we'll get back from the backend. And when we do that, do notice that the structure should mimic exactly what we have inside our database models list. So our model will have a title of type string, and that's it. And our task will have a title of type string and a list ID of type string, obviously, and completed of type boolean. So let's do that. Let's create the task model first. So let's create the list model first. I think class list, and we can just, first thing we'll need is ID, which would be of type string, and then we'll need title, which will also be of type string, and then we can just export it. So we can export it from here as well. Export default class list. This would work. And now we will create a class export default class. The name of the class would be task, and then we can define the properties. So ID is going to be there, which is of type string. Title is going to be there, which is of type string, and then there's list ID, which is also of type string, and then completed, which is going to be of type boolean. So now that we have created our models, this will allow our Angular application to understand the structure of the response that we're going to get back from the tasks. Now what we can do is we can just, so we need to firstly get the web service.ts files instance. So we create web service as web service and we import it automatically, and we have an instance for that. Now let's create methods to send requests to our backend. So firstly we'll send get lists. This method will get all the lists. We can do return this dot web service dot get, and inside the guest we need to type in the URL. So if you remember correctly, this we don't have to pass in the slash, so it's slash lists, and this will return all the lists that are inside our list collection. So we look into this. Inside the list, getting all lists, localhost 3000 slash lists, and this is what we get. Now we'll create a method to create a list. For that we need a title, that is the title of the list, which is of type string. And what we can do is we can just return this dot web service dot, and if you want to create a list we need to send a post request to lists, and this will have a payload with title. Now the title will be sent back to our web API, and it will create a new list with the title and return us the response. Similarly, we can create two more methods for creating tasks and getting all the tasks. So instead of create lists, get lists, we have get tasks. And lists, because we need a list ID as well of type string slash lists slash, and we need to convert it into template literals, template string, and then we pass in the list ID and then tasks. So we have a URI that is localhost 3000 slash lists slash the list ID slash tasks. Similarly, if we want to create a task, we need to have the list ID as well as the title of the task. So list ID should be string as well. Then the URL is the same as this one. Just make sure that you are using template strings, and the payload should be the same as well. It should be title. Yeah, it should be fine. And here list ID should be. So we now have the ability to get the lists, create the lists, get the tasks, create the tasks, and let's implement all the functionality while we're at it. Now let's create a method to delete the list and all the tasks associated with it. So to do that we need to create a method named delete list. This will take again a list ID of type string, and then we return this dot web service dot delete, and the URI that we need to respond to is slash list slash dollar list ID, and we need to convert it into a template string. So this is done, and lastly we need to create two more methods. Delete task, it will delete a single task, so we need a list ID, task ID of type string, getting the list ID, then we look at the tasks and slash task ID. So this works. And finally we need to update, we need some mechanism to update our lists or tasks state. Now all we're doing when we're updating a task is we are setting our task either to completed or not completed. Now this is where it gets a little tricky. So we'll accept the entire task as the argument. It will be of the task model, which will import. As you can see, it's imported, it's task, and we can return this dot web service dot patch. So you can use put as well, I think. Okay, let's see. Web service, we have used put, and okay, so we have made certain mistakes here. It's going to be post. This is going to be, instead of put we can use patch, patch, and here instead of get we get to use the delete method. Okay, now that that is done, let's open task service, and instead of put we use the patch method, Inside the patch method we need the string, which is the URI. So to set it complete we need lists slash, we need a list ID as well. So list ID as string. So first things first, the list ID, then we tasks slash, and then we use the ID of the task dot ID, and payload would be, okay, let's see what the payload should be. So what we need to do is change the completed field to the opposite of what we have right now. So the task completed. Now since it's a boolean field, we can just use the not operator and it will convert true to false and false to true. So when we click on the task, if it's completed, it will be marked as incomplete, and if it's incomplete, then we click on the task again, it will be marked as complete. So that now that this is done, let's see what else we need to do. So the service, we have created the services, and since these are marked with the injectable decorator, we can inject them in our task view component.typescript file. So let's see how this works. So let's begin. The first thing we need is, let's see what our task view component does. It will keep a list or an array of lists. This would be list. So this would be an array of lists. Initially it would be empty. Similarly, it would have an array of tasks. For that we need to import task, and this is done. And inside the constructor we need a reference to our task service. So private task service of type task service. This is done. Now we'll be using the ng on init hook. So what ng on init does is, after the entire component is loaded, the code inside the ng on init will be executed. So that way, if we ever access anything on our web page, such as an HTML document, it won't be accessed before it's loaded on the page. So now what we need is, we need to use the this.taskservice.getLists, and inside the lists we'll need to subscribe it. So when we use the HTTP client module from Angular, we get the results back as an observable. Observable is a type in RxJS which allows us to use methods like subscribe and so on and so forth to use with asynchronous data. So as we remember when we created our API, that it was asynchronous, which means that when we send a request, it will be processed in the background and the response will be sent back when the request is completed. So the subscribe method allows us to explain the code or type in the code that we wish to be executed when the result is received. So we type subscribe, and when we use the getLists method, we'll get a lists variable, and what we will do is this.lists is equals to lists, and we're getting an error. It says object is not assignable to type lists. So let's first, and now it works. So let's see what we have to do now. And now if we look into our application, as you can see, the updated title is showing here. Let's add some more titles. So we go to lists, save lists, and we type in the name list. Let's type 1, and 1 list is created, 2 lists, and 3 lists. Now what we wish to see is 3 lists, and yes, we see 3 lists inside our application. So these are 3 lists from our backend API, so it's working correctly. Now let's see what else we need to do. Okay, so now that we are done with our fetching the data from the database and displaying all the lists that are in the database, now we need to take care of certain things. First of all, we'll need to take care of displaying all the tasks related to a list. So to do that, first thing we'll need to do is we'll need to go to our front end, go to our source folder. Inside our app folder, in the routing module, we need to create a new route, and this one would go to /lists/list ID. So the way we're thinking about doing this is, what we can do, we will have this URL localhost 4200 /lists/ and some random list ID which we'll get from the database, and when the user clicks on certain list, this ID will change, and based on this ID we will fetch the tasks related to that list and then display all the tasks into the task list. So let's try and implement that. So the first thing we need to do is we need to just register the route, and we have lists, list ID, component, task view. Now so we can just remove, okay, yeah, so this is the URL we wish to go to. Now we need to open our components, our task view component, yeah, this is the file, and we need to inject a few more properties. So the first thing we want is the current route, so we get it using the activated route. This is pre-built into Angular, so we don't have to do anything, and as you can see, Visual Studio automatically imports this for us. And finally we need the router, so that when the user clicks on a list, we can redirect him to that list. So for that we need router. Okay, now that this is done, let me indent this a little, let me unindent this, yeah, this looks fine. And after getting the list, since we have the tasks list, what we need to do is this dot root dot params dot subscribe. So whenever the route changes, this function will get called, and we will get the param, and we look into it. So we get list ID param, and since we have the list ID right now, what we can do is, okay, so we have, okay, let's type this as well. It will be of type param. I think it's inside, yeah, so let's import this. I think pa params, and we are okay. So in the list ID parameter, we take it into a constant variable named list ID, and then we check if list ID, which means if the list ID is not null. So if it's null, then we just return, and we don't need to fetch anything from the database. If it's not null, then we go this dot task service dot get tasks, and we pass in the list ID, and after that we subscribe to it, so that when the tasks changes or we get the result back from the database, we assign it to our tasks property. And to do that, first we'll type it. So this will be type this, and we go tasks is equals to, we have to, yeah, this tasks. So the parameter will then be put into this. Okay, now that we have that, yeah, this is working. Let's look into our templates to see what the changes we need to make, and yeah, here it is. So we need to make some changes so that this looks, yeah, so this is the template that we need to repeat so that we can display tasks. Here instead of task, we need the title of the task, and we need to conditionally apply this class of complete. So if the task is complete, then we need to apply the class of complete, else we don't need to apply the class of complete. Now doing this manually would be a bit tiresome, but thankfully Angular comes with some functionalities that allow us to conditionally apply the classes to template elements by looking at the data that we have. So let's see how to do that. So let's use the ng4 directive that we had already used to display our lists, and let task of tasks. Similarly, like we did for the list, which is here, let list of lists Similarly, we're doing it for task, like task of 4 tasks. Here we need to display the task dot title. I think it's title. Let's see, tasks. Inside the model we have given it the title property. Yeah, so it's tasks title. And now for the class application, we tell it the class, and we want the class of completed. So, and we wish to show it when the task has the completed property set to true. So we use this. So it says apply the class of complete, that is to say that name the class complete when our task, which is this variable, is complete. Now you can also see this, but this is a bit redundant because it's only going to evaluate to true, and the value of this task.complete is what we're looking for, whether it's true or false. So you can just omit that. So we have displayed the task for all the tasks that we're getting, and here's a component. So what happens is when we go to list/list/list id, all the tasks associated with that list id are fetched back, and then what we do is we display all the tasks inside the list, and if the task is complete, then we apply the class of complete, else we don't. So let's see if completed. Yeah, so task.completed. This was a mistake, and let's see now if it works on. Okay, so let's see if it's working, and okay, it's not working. So let's see what the issue is. The issue that I think we're facing, oh okay. So we need to change it to not list id. So if the list id is null, which is, yeah, so if it's null, then not null will return true, and then it will return okay. That would be the issue, and we can remove this. This is just for. And one other thing that I think we should see, yeah, it's task, not tasks. And if we look, yeah, so it's working. Now we need to implement the functionality that when we click the list, it should be marked as completed and sent back to the database so that it's updated there as well. So to do that, let's go to our code again. We need to create another function. You can call it anything we want. I can call it on task click. So when the task is clicked, pass the task, and this dot task service dot set complete. And let's see what the set complete method does. So when we send in a task, what it will do is it will set its complete property to the opposite of what it is right now. So if it's complete, it will be set to incomplete, and if it's incomplete, then it will be set to complete. So let's go and complete this. So to complete it, what we need to pass is the list id and the task. So the list id and the task, we need to pass it, and one thing that we can do is we can just store the list id instead of having to grab it from the params again and again. Now you can grab it from the parameters, but I like to store the things that we need to use again and again. That way, instead of duplicating the code, we can just reuse something. So this will work, and now when we set completed, we need to pass the list id, which is this dot list id, and we need to pass in the task. Now the task will be passed to us in the parameters, but we need to type it. So yeah, so this is the type, and we pass the task, then we subscribe to it. Subscription will allow us to respond in our application to the response that we get from the server. So if the response is success, okay, we will display some message, or in this case show it as completed. If it's not, then we'll show some error. So let's see how to do this. So when we update a task, what happens is the task is sent back. So the task is sent back. So what we can do is that we can just set the current task. completed property to be the opposite of what it is. So if it's completed, if it's not completed, then it's completed, and it's completed, then it's not completed. So after doing that, let's see if it works. Let's see if there are any errors. So far there aren't. Let's refresh this for a second. Okay, it's working fine. And I click. Oh, okay. We need to wire this function in the template. So in the template where we are displaying the tasks, which is here, now we need to respond to an event. Event handling in Angular is done by wrapping the event inside a parenthesis. So we want to respond to the click event. Now when the click event occurs on this task, we wish to call the method on task click and pass in the task. This task is the task that we are displaying right now. So this is the task. Now let's see if it works. So there are no errors as far as I can see. Yes, there are no errors. Click on it and it's yes and yes, and it's getting marked as such. Let's see if the server is responding to this as well. So if I refresh this, it should keep the same. Yeah. And for final sanity check, let's see if when we get all the tasks, 2 of them are marked as true, which are task 3 and task 2. Task 3 and task 2 are marked as true, and we are getting the styles that we need for our application to display the tasks that are completed. So our completed task functionality works fine. Now all we need to do are a couple of things. So let's see what we need to do now. Okay. So we have created a basic task list. Now we need to be able to navigate to other tasks or other lists. So for instance, if I click on this list, then I should be navigated to /lists/ the ID of this list. This is where the router comes in. We'll use the Angular's built-in routing functionalities to route us to this route. Secondly, what I want is right at the beginning, I want to, when I go to localhost :4200, I wish to be redirected to lists, and that should be showing this list without any tasks. And when I do this, I go lists, and yeah, so this is the tasks that I'm getting shown. And then we need to implement the add list functionality, and also we need to implement the add tasks functionality. There'll be a button in here that will show you how to create a form and then get the data and then send it back to the users. So let's begin by implementing the first functionality, and also we need to implement the functionality when we delete these lists. So to do that and delete the tasks, first thing we'll need to do is we need to create the navigation. So when we click on this list, right now all of them are marked as active, so we don't know which list is being displayed right now. So let's see how to tackle this. So inside our template, as we can see, we have this isActive class. Now if I remove this and then I go back to our class, you can see that this is marked as, all of them are then displayed as simple list items. So what we need to do is we need to, let's see, list ID. So when I go to this list item should be marked as the active list. So to do that, thankfully again Angular has its own built-in functionalities, but for that firstly we'll need to create new routes so that we can implement the functionality. So this is done, list ID is done. Now when we are logging on to our home page, we want to be redirected to lists, and it should be displaying task view component. So to do that, I think what we need to do is redirect to is the property that we need, and then we need to pass in the properties there where we wish this URL to be redirected to. And for that, what we need to do is first we need to remove the component, since we'll be redirecting it. Redirect to, instead of it being a component, we need to redirect it to lists. So this is the URL that it gets redirected to, and we want it to be, this is working fine, but we need to add one more thing for the Angular router to work, and that is the path match to be full. Now what Angular router will do, if I had this one at the beginning, then it will match this. It will say okay, lists matches to this URL. Although there is a suffix to this or a prefix to this, we will redirect it to this URL, and we wish for it to redirect it to /list, not to /list /list id, because we do not have a list id yet. So if we save this, I think it should work. Let's see. Yeah, so we are getting redirected to /list when we go to our home page. That's working fine. Now let's see what else do we need to do. We need to then on click redirect to other URLs. So for that we need to go to the template and handle the on click or the router link functionality. So this is the anchor tag. Now we do not wish to use href because href will redirect us and reload the page, and we want it to be a single page application, and we want JavaScript to bring in the pages that we want to see. So for that there is directive that we can just insert in our template. These are all provided by Angular. So this is router link, and the way we pass it something is we pass it an array. Now we can pass it just a single root if it was not a root that expects a parameter. So in our routing module we can see we need list, and then we pass the list id. So what we need to do is we tell it okay, lists, and to that list at the end of that add the list underscore id. So we'll get redirected to that list, and finally we want to apply the activated class if it's isActive class, if it's the link that's been active or it's the link that's been clicked right now. So to do that, again Angular provides us with built-in functionality to check if the link is active right now, and we can apply classes conditionally too. And to do that we don't need to use this bracket syntax. We can just use the directive router link active, and then we add the class which was isActive. Save that and see if it's working. So /lists, click on updated title, okay, and then we are getting redirected, as you can see here, to other pages as well. So our list is working really well. Now we need to implement the functionality to delete a task. So when I click on this, it should delete. When I click on the list, when I click on the delete button on the list, this entire list should be deleted, as well as the tasks related to that list should be deleted. And then we need to add the functionality to add the task, and then there should be a button to add tasks, and then a form to do that. Similarly, for adding a list, we need to have a button and then a form to do that. So let's begin. First thing we'll do is we'll implement the functionality to delete a task. So for that we need to add a click event handler on this button or on this span. So if you look at the HTML content, actually you can just look at the HTML content inside our template. So this delete button is being shown here. This is where we are showing the delete button, and we wish to add an on click method. So similarly we did previously, click is equals to delete task, name of the task would be task. Again this name comes from this. However, we don't have a method called delete task yet, so we can go here, delete task, inspect a task of type task, and inside the method we'll just show what the task looks like. So I've misspelled task. Yeah. So now that this is done, look into the console, and when I click on the task, it's marked as complete or incomplete, and when I click on the delete button, this task is being passed as the parameter. Similarly, if I click this button, this task will be passed as the parameter, so on and so forth. Yeah, so it's working fine. Now let's see what we can do. So the first thing that we'll need to do is use our task service dot delete task. This will be expecting a list ID which we have stored right now. Sorry, list ID, and finally a task ID. We can pass the task as well, but since we have the ID right now, let's just pass the task ID. Now when the task gets deleted and we get the response back, we subscribe to that response, and in the response we'll be getting a task. So now we need to filter our task list so that the current task is removed from the list of our tasks. So if it has 4 tasks and I delete the third task, then for first, second and fourth task should be what we see. So to do that, we can simply use the JavaScript method of filter, this.tasks.filter, and we'll get the task as the method, and we want the task whose ID is not equal to task dot. Okay, I need to type it as well so that Angular knows what I'm talking about. Yeah, so this should work. There are no errors inside our console. There are no errors as far as I can see. Yeah, in our production. Yeah, so if I delete this, okay, we're getting an error. Type error, cannot read property ID of null. Okay, so to debug this, what we can do is firstly we'll console.log the task to see if we're getting back what we're expecting. If not, then we'll have to tweak our API a bit. So let's see, we click on 3, it gives us the task, that's fine, but it's not removing it. This is the problem. And when I reload, yeah, so the task is being deleted but it's not being removed from the list. So to tackle that, let's see what's going on. Oh, okay, we're filtering the task but we're not assigning it. This.task is equal to, so what happens is we create a new list. So let me just show you in the console. Firstly, I'll just, yeah, this is working. Now let me just show you. So let's say that I have 8 tasks with the ID of 1, 2, 3 and 4. Now the task that I want to delete is of ID 3. So I can use the filter method, in which I just say give me the tasks where task is not equal to 3, and what it does is that it returns a new array. Now the problem is the original array that we are rendering still has the element that we wish to delete. So even though it's deleted from the database, we still have it in our memory. So to tackle this, what we need to do is just reassign it. So now the tasks will have the filtered list that we want, and this is the list that we wanted, and this is the list that we use. So now that this is working, so the deleting of the tasks is working as well. Now finally we need to implement delete list, and it's very similar to this. So delete task and delete list. For that we need to do the same thing. Here it is. Just add a click event handler, assign a method which would be DALETE list. We will pass in the list. This is the list that we'll be using, and we are getting this list here. So now go to the component, create a method named delete list, which accepts a parameter of list of type list, and simply sends a request to the task service to delete a list, and inside it we just need to pass the list ID of the list. Make sure that you're not passing in the list ID of this dot underscore list ID. So the reason why I'm saying this is because suppose you have this list and I want to delete this list. If I click on this delete icon, I don't want the currently selected list to be deleted. So to prevent that from happening, we need to pass the list that is under that the user clicks, and then delete that and that list alone. So after that we just subscribe, and we do something very similar here. Just replace task with list. We will get back a list of type list. This dot lists, which is the list or the array of all the task lists that we have. So we get the list and we set it equal to the lists.filter L. Lists ID should not be equal to the ID of the list that was returned from our database. If we save this and we go back, refresh, see if there's any errors. There isn't. So if I click here, is it getting deleted? No. Why not? Cannot read property of null. If I refresh it, we're getting the same issue again. I think we have run into the same problem. So when we subscribe, we set this list is equal to this list filter, where list ID is not equal to the list that we are getting back from the task service. So this should work. Let's see what's going on. Okay, maybe we don't need to do this. Yeah. Okay. Now I think it should work. Yeah, it's working. So the problem was that we were sending a response back and we were taking the list for that. What we need to do is we need to remove the list that the user clicked currently to delete, and then remove that from the list, and that's what we're doing. So this is done as well. Now the 2 or 3 tasks that are remaining are for us to add a button for the user to be able to add a new task inside the selected list, which is these ones, and another form to add list and another form to add task. These are the 3 tasks that are remaining, so let's implement them. So let's first close all of these, and to implement the add button, first we need to add a button. So again we will open our template. Now to add a button, what we can do is we can add an image with a button. So the image would be of plus symbol, and then you can add it. So let's see what we can do about that. Okay, so what we need to do is we need to add a button, and then we add some default bootstrap styling for button primary, and add task, and let's see what our styles do. Our styles have an add button. Okay, so we use this class, and let's see. Okay, so yeah, this is the task button we have. Now if you're wondering how is this looking like this, how is it being positioned at the bottom right corner, so what we do is it's in our CSS we have an add button class which makes it a position absolute. Now what absolute position in CSS does is it looks at all of the parents, and the first parent that contains the relative positioning, so ours is absolute, and the task container I believe contains the relative positioning. Yeah, task list container has the relative positioning, so it is being positioned relative to this. So in our styles we have instructed that we need it to be 35 pixels from the right and 35 pixels from the bottom. So 35 pixels from right and then 35 pixels from bottom, and this is where it lands. Now if none of its parents had the relative position relative attribute, then it would simply be adjusted relative to the body. So to show this, body of the HTML page I mean. So this is the container relative positioning. If I remove this, now 35 pixels from the bottom, 35 pixels from the right, and it's positioned at the bottom right of relative to the HTML page's body instead of the task container. But since we want the task container, so we have put relative positioning on that. So that is done. And now finally what we need to do is we need to create 2 more pages. These pages would be containing forms, and these forms would allow us to input some data into them and then click on add. So let's try and do that. So when I click on add list, I should be directed to a form that takes a list name as the input or the list title as the input, and then when I click on the add button, it should add me or add the list to this already existing list of list titles. And then when I click on add task, when I selected this list, the task that I'm giving should be added to this list. When I selected this list, then the task that I'm asking to be added would be selected to this list. Now to do that, firstly we need to generate 2 more components. which are two more forms for us to add some data through. So let's do that. Let's go to remove this, and we will generate two more components. So let us generate the two components that we need. So let me create another terminal instance. Okay, it's inside the, let's cd into our front end, src, cd into the front end. Look at the directory. We have the src folder we need to cd into, and then if we look, we have the app, the assets, the environment. We need to cd into the app folder, and here we have all our components. We have the app component, the routing module, and task service, web service, models, and pages. So the two components that we are going to be generating for creating a new list and for creating a new task will be stored into the pages folder. So to do this, we need to type the command ng generate component, and the component should be inside the pages folder. And the first component we need to generate is a form so that the user can add new lists. So we can just name it new list component, and when I press enter, similarly if I want to, I can generate a new component inside the pages for new task. Now in Angular CLI, since typing ng generate component can be a bit long, they have given us a few other commands that are quite shorter that do the same thing. So I type ng g, which stands for generate, c, which stands for component, and then the path. So new task. We had generated a new list, and now we're generating a new task, and yep, it's generated. So now when we look into it, this is the new task, this is the new list, and finally the last thing that we need to take care of is the routing part. So let's add some new routes. So when we navigate to new list, it should display the new list component, and the new task component would be when the user clicks on a list and then clicks on a task. So that list with the list ID and then new task. This will show the user a new form with the list ID inside the URL, and when the user adds a new task, it will be added to the list with the list ID that is passed as the part of the URL. And for that we need to use the new task component, and that's it. Yeah, so this is done. Now we can close our routes. Let's go into our dashboard component, which is the task view component. Inside the HTML we have this. Now what we want to do is when the user clicks on add task or when the user clicks on add list, we want the user to be redirected back to the new task or the new list component that we just created. Now Angular again makes it quite easy for us to do that. We just use the router link directive and we give it the link that we want it to go to. New list, save this, and now when the user clicks on the add list, it will show the new list component. So we go to add list and it shows new list works. So this is working. Now that is done, let's do one more thing. Now since it was very easy to do this because all we had to do was to instruct the page to go to the /newList, it was very easy, but we can't do the same for any of our other routes. So for this add task, we need to handle it inside our TypeScript file. So we just say add task click. So now we need to create this method inside our TypeScript file, which is here, and so now whenever the user clicks on this, what we need to do is we need to use the router that we had already imported and instantiated. So first thing we need to check if the list ID is present, because the logic is a little complicated, which is why we didn't hard code it inside our template. Whenever the logic gets a bit complicated, it's very good idea to push it back into the TypeScript file. So we check if list ID is not null, So if it is null, then we just wish to alert the user. Now you can do it in many other ways. You can have a dedicated component that will show the alert to the user, but for our purposes we'll just show a simple JavaScript alert, and it will say please select a list to add tasks. That's it. Now we need to return it so that any code that we write after this is not executed. Now if the list ID is present, then what we can do is we can just use this router.navigate, and navigate will take commands. Commands are basically just arrays that contain lists and parameters. So we want the user to be redirected to /new task, and we want the URL to be relative to, I think that's the path. No, let's see what we can do about it. So we need to pass in a inside the extras we pass relative to, and we pass in this. Instead of doing this, we can do this dot root. Now since we have already stored the current root inside this dot root, we can just redirect the user to that. Save this, and now when the user clicks on add task, it should show this. So we are getting this, and now let's look at our edge condition. When the user is /list, click on add, please select a list to add task to. The user looks at the message, selects a list, clicks on add task, and it's working. So our navigation is done. Now we need to create the two forms. So let's do that. For that we will need to look at the components. So let's look at the components. We have the new task list components template and the new list component template. Now we don't need the default this new list works or new task works. We will need to create our own template. So to do that, first we'll create a centered content div. So I think I have centered, and then we need to create another div with modal box and the class of form -group. This is a default bootstrap class. And now we need to create, first of all, let's create a title. This will show the user title to create a new list, and then we get an input of type text. Class would be form control, which is again a default bootstrap class. This is why we imported the bootstrap HCSS framework, and it would be a background light. This will give our input a light or a white background, that way it stands out from our dark theme. And then we need to give it a placeholder text. So name of the list, enter list name. Now we need two buttons, btn. So the two buttons will have add, cancel. Let's see if it's working correctly. So I click on add list. So we are showing the list, but the buttons are not showing. Let's see why. Inside the form we have placeholder, and I think I forgot to save. Do we have an error? No. Create a new list, enter the list name. So buttons are showing, but okay, so we need to add the background color. So we can do is, the add button would be the primary button, btn primary. Save this and then look at this. Yes, so it's showing. And let's look at others as well. What can we do? What the cancel button has, so I can do, I think there's a white text color that I had added. Yeah, so cancel, add. So it's looking okay. So now we need to add the functionality. So when we click the cancel button, we want the user to be redirected back to the home page. And here what we can do is when the user clicks on add click, we want to call the add list, and we want to pass in the list type. So the value of this input needs to be passed there. The problem here is that we don't have any way of referencing this. Now again, Angular makes it easy for us. We can create a template reference. We can call it list input, and now all we need to do is pass in the list input dot value. So when the user clicks on this add button, this function will be called, which we need to declare here. And let's do this. Add list should have a value of string, and now what we need to do is, now we need to use the task service. So we import task service, type task service, and it's imported. We need to make it private, so it's not used anywhere outside the class. Now this task service dot create list, and inside it we need to pass the title, which we are already getting as the value parameter, and then we subscribe to it. Now what do we wish to happen when the list is created and we get a response of 200, which means the list was successfully created. Now to do that, we need to, what we want to happen is we want to redirect the user back to the new list. To do that, what we can do is, first we need to import the router so that we can redirect the user or cause the user to navigate to another page. So we instantiate the router, and it's imported and instantiated for us. Then what we do is that we get the list as the response, the newly created list, which is of type list, and then all we have to do is drop it to a new line so that it's easier to read. And then we go this dot router dot navigate, and we pass in the command is an array of the roots and the parameters. So the root was lists, and then the parameter would be list dot underscore id, and that's it. And let's see if we are getting any errors. Not so far. Okay, that's good. We create list of title sam list, click on add list, and we are redirected to the new list with the new list is selected. Now we need to do the add task, which is extremely similar to what we just did. So again, this is the new task component, and let's see what we have to do. Now since it's quite similar to the one template that we just created, we can just copy it, change the appropriate. So form group, create new task, list input. Make sure that you don't leave any discrepancy. Here we don't want to redirect the user back to the home page. We want the user to be redirected back to the list. So the route that we'll be getting would be localhost colon 3000 slash lists slash list id, and then we'll go to the new task. Now if the user clicks on the cancel button, we want the user to be redirected back to the list. So this should be the URL that we want the user to be redirected to, and in Angular we can just do it this way. This is similar to how you would navigate a folder structure by navigating a folder up in the directory. So this is done, and now instead of add list, we can create add task, and it should be task input. Yes, so it's done, and now we have to do this. Now here it's a bit complicated. We have to do all the things that we did there as well. So the first thing, task service task service. Similarly, we need to have the router for the user to be redirected back to. And finally, one more thing that we didn't have in the previous component that we need to have here is the activated root. So if we're doing router, we need to call it root and activated root and a list ID. Now what we need to do is this dot root dot params dot subscribe. So when the root changes, we will get the params. We need to type it so that Visual Studio can understand what we're trying to do, and we need to set this dot list ID. Params dot list ID. So now that is done, finally we need to create this method. Just copy it in order to avoid naming issues. The value should be string. It should be called, value should be of type string, sorry. We call the task service, we call it create task method. It expects a list ID which we pass as the this list ID, and then it expects a title which is the value. Then finally what we need to do is we need to subscribe to it, and when we get a response back, we just redirect the user back to the list. So what we do is we use the this dot router dot navigate, pass in the commands which is just same as we did previously, and we need to pass in the relative to attribute which is this dot root. Now that is done, let's see if our application is working correctly. So we go to updated title. There are two list items here. We go to list 1, there are no tasks. Let's add one, call it task 1. Now if I click on add, we get it here, and let's see if our cancel button is working. It's working. Let's see if I add task 3, add, it's working. Now if I click on the task, it's marked as completed. Click on the task, it's marked as incomplete. But delete this task and then go back and then come again, it's deleted. Now let's see if I delete this. Let's look at Insomnia, get all tasks, and we have delete my list task. So we need to pass this list ID. Send, and this is the one task that we have. Now if I delete this list, go back to Insomnia and send it request, we don't get anything because the task has been deleted and the list has been deleted as well. So these are the two lists that we have, sample list and updated title, and all the tasks related to the list that we deleted have also been deleted. So our application is working as we expected it to work. The front end is done, so is the back end. Let's see if our back end is working. So this is the front end, this is the back end. We're getting an error. Oh, this is the error because we tried to access a task that does not exist. This is fine. So our back end is working completely. So is our front end. So we can close it all off. And as you can see, building application or a single page application using Angular was quite easy. The main advantage of using Angular to do this was that we can separate out our application concerns into smaller chunks. So we could make 3 components for the 3 pages. We can create models to describe the shape of our data, and we can just create the modules and the components and so on and so forth. Also, we have extracted out common logic into services like web service and task service, and this is all done. So now that that is done, our application is entirely built. Now you can see that we have separated our front end and back end, and if I were to change anything in the back end, the front end will not be affected. Similarly, if I were to change anything in the front end, the back end will not be affected. So this goes on to show how easy it is to use the mean stack once you know the basics of JavaScript, and how easy it is to create two separate components for front end and back end and then merge them together.
Just a quick info guys, Intellipaat does provide end-to-end training on MeanStack. So if you're interested, you can check out the course details given in the description below. So this brings us to the end of this session. I hope it was informative. If you have any queries, you can leave a comment down below and we'll reach out to you immediately. Thank you.